Okay. First of all, we know that we use models to show things that are too small or too big or too dangerous or too far away to be easily seen or represented. Does that make sense? Okay, and in this case, we are going to use models for atoms because models are too what? Small, big, far away, or dangerous? Small. They're too small for us to see. Okay? All right. So we're going to use different models depending on what we need to study. Okay? We are going to pick certain models, particularly for an atom. We may need to show how an atom forms chemical bonds, and so we're going to need to make sure that we model electrons so that we can show how they're involved in chemical bonding. So anyhow, we'll just quickly overview the three models that they talk about on this particular page. So the electron cloud model is this one over here. Okay. And it's nice because it shows how electrons are found in a region around the nucleus. The Bohr model shows us the number of electrons in an atom, and it also shows us what? Yeah, okay, so a Bohr model actually does not show us the true arrangements of electrons. It just shows us energy levels. And so each energy level, it's not like electrons sit there on a ring around the nucleus, but the rings represent different energy levels. Does that make sense? Okay, and so the ring that's closest to the nucleus is the lowest energy level, the ring that's next is the next highest energy level, etc. Okay? So this over here is a Bohr model. Have you drawn any Bohr models ever? Yes. Okay. All right. Then we have the space-filling model. Here we go. Which is helpful because, particularly with compounds, it shows how atoms are arranged in a three-dimensional setting. Does that make sense? So a space-filling model, the atoms are represented just as solid spheres. And it's really helpful because this model can show how the atoms are connected to each other. Okay? So just three different types of models. You've seen them all, I think, before. Okay? But electron cloud, which shows you kind of a more accurate description of the electrons, that it's just simply found in a region around the nucleus. Then you have the Bohr model, and that's helpful because we have the rings representing energy levels. And then the space-filling model with just each element or each atom represented by a sphere, and you can just kind of show the three-dimensional shape of compounds. Is everybody okie dokie with all that? Okay, let's move on to page 141. Okay, so since we're already familiar with a Bohr model, this should not be shockingly new to you. Okay, in the center, the red and white are representing what? Nucleus. Yeah, the nucleus, protons and neutrons. Okay, we know that the first energy level can hold up to 2 electrons. Do y'all remember learning that? The second energy level can hold up to how many? 8. And what about the third? 8. Things get a little more complicated after the third energy level. And so we probably in here will not go past the third energy level. Or if we do, it'll be barely into the fourth. Okay? All right. We've already talked about what valence electrons are, but we're going to talk about them again. Why are we talking about them again? I don't know. Waste time? No. Because they're important. Oh, talk about things over and over if they're important. All right. Bohr models show atoms, electrons, organized into energy levels. We've already seen that because we've actually drawn some Bohr models already. And each energy level can hold a specific number of electrons. The first energy level can hold 2. Okay, the second energy level can hold 8. Okay. And you need to realize, I think you already do, but electrons are usually not added to additional energy levels until the lower levels are full. So you have to fill the first to begin on the second. You have to fill the second to begin on the third. Does everyone understand that? Yes or no? Oh, they're so quiet. Okay. The energy level shown furthest from the nucleus in the Bohr model is called the outermost energy level. And the electrons found in the outermost energy level have a special name. And what is it? Valence electrons. Okay. Why are valence electrons important? They are the outermost electrons, and they are doing what? They are the only ones that are involved in chemical bonding. Okay, so that's very important. So important that I might take a few seconds and write that down, even though I know it, but let's write it down one more time. Valence electrons are the only electrons involved in bonding. So I can say valence electrons are the only electrons involved in chemical bonding. I can say valence electrons are the only electrons involved in chemical reactions, etc. Are y'all okie dokie with that? All right. Number 12, it says a fluorine atom has 9 electrons. Draw a Bohr model to determine how many valence electrons the atom has. Well, first of all, they just put an F in here to represent the nucleus of a fluorine atom. We know that it has 9 electrons. Step 1 is to add 2 electrons to the first energy level. Why are we adding 2 to the first energy level? Because that's the most that the first energy level can hold. How many electrons still need to be added? Well, we had a total of 9 that we had to do something with. We have taken care of 2, so we still have 7 to deal with. Okay? Is everybody okie dokie with that? All right. Add the remaining electrons to the second energy level. Okay. How many electrons still need to be added? 7. How many electrons can go in the second energy level? 8. So all of my 7 are going to go where? In the second energy level. I have room for all of them, so I'm going to draw 7 electrons. Okay. One more time. Energy level shown furthest from the nucleus in a Bohr model is called the outermost energy level. Electrons found in the outermost energy level of an atom's Bohr model are called valence electrons. Therefore, how many valence electrons does fluorine have?
9.
7. Why 7? Because there are 7 electrons in the outermost energy level. Got it? So how many electrons does fluorine have that can get involved in chemical bonding? 7. There you go. So we're now on page 142. How does the periodic table show the number of valence electrons? It's actually really helpful to have the periodic table when you're trying to figure out valence electrons. You can determine the number of electrons and valence electrons in an atom of an element without a Bohr model if you'll use the periodic table. So the atomic number of an element, remember, tells you the number of protons. Does that ring a bell? If we can assume the element is neutral, it also tells you the number of electrons. Still with me? Okay. So the number of electrons in a neutral atom is also equal to atomic number. So elements in the same group or vertical column have the same number of valence electrons. How do we know that? Just because of the way that the electrons are filled by energy level. If we consider down here our periodic table, hydrogen has 1 proton. If it's neutral, it also has 1 electron. And since it's the only electron, how many valence electrons does it have? Just 1. Okay, we go over to helium. Helium's atomic number is 2, so it has 2 protons, and if it's neutral, it has 2 electrons. And how many valence electrons will it have? Just 2. Okay, because you fill that first energy level, and it can hold 2, and it's got 2 to hold. So, all right, then we move on to lithium, which is element number 3. Lithium has 3 protons, and if it's neutral, it has 3 electrons. 2 of those electrons go in the first energy level, and then 1 goes in the second. So how many valence electrons does it have? 1. Same with hydrogen, right? Hydrogen had 1 valence electron. Okay. Let's skip all the way to sodium. Sodium has 11 protons. If it's neutral, it also has 11 electrons. Well, 11 electrons. 2 can go in the first energy level, 8 can go in the second, and it has 1 in the third. Does it make sense? So it has 1 valence electron. 1 valence electron, 1 valence electron, 1 valence electron. Potassium is the same way. Rubidium, cesium, francium. They're all the same. Everything in column 1 has how many valence electrons? 1 valence electron. 1 VE. Got it? I've said them a million times before, I guess. Okay, in column 2, let's do beryllium just for fun. Beryllium has an atomic number of 4. If it's neutral, it also has 4 electrons. 2 goes in the first energy level, which leaves 2 for the second energy level, so it has 2 valence electrons. Everything in column 2 has 2 valence electrons. Okay? Now, point out something really important to you guys. It says you can use the group number to find the number of valence electrons in groups 1 and 2 and 13 through 18. But there's no simple rule to find the valence electrons in group 3 through 12. They're talking about these. So do we usually try to find the number of valence electrons for these guys? No simple rule. Frowny face. So when we're trying to determine valence electrons, we're typically dealing with the tall columns on the periodic table. If you wind up in chemistry in college, then you may, start figuring out what the deal is with these other ones. But we're not going to deal with that at all. Is everybody okay with that? Okay. Now, I've got 1, 2, and then on this periodic table, the short columns go 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. And then we resume the tall columns with 13, 14, 15, 16, 17, and 18. Does everybody see that? Some periodic tables, like this one, okay, this is actually the one, let me see if I can turn off this. Okay, well, so I'm sorry about the glare, but these columns are A columns, the tall columns, and the short columns they designated as B columns. Okay, so sometimes, and for instance, this is the one for the STAR test at the end of the year. 1A, 2A, and then this is, instead of 13, it's 3A, 4A, 5A, 6A, 7A, 8A. Do y'all see that? And the numbers tell you the number of valence electrons. Everything in column 1A has 1 valence electron. Everything in column 2A, 2 valence electrons. Remember, we skip the short columns because there's no nice predictable rule. Okay, we go back over here. Column 3A, everything in that column has 3 valence electrons. Are y'all seeing this? Everything in column 4 has 4 valence electrons, etc.